Today's problem is sum of nodes in BST range, binary search tree. Difficulty is medium, accuracy, I've never seen an accuracy that high, 93%. Submissions, this must be a new problem because there's only, like 1,000 submissions. Given the root of a binary search tree and two integers, L and R, the task is to find the sum of all nodes that lie between L and R, including both L and R, okay? It's pretty self-explanatory. So here's the nodes in a tree. You need to be greater than or equal to 10, less than or equal to 22. There are three nodes that meet that criteria, 12, 20, and 22. And so it comes out to 54. What is this one? 11 to 15. There's only one node in there. That's the 11. Constraints. Number of nodes is between 0 and 10 to the 4th. And let's see, the data points, data in the nodes, also between 0 and 10 to the 4th. L and R are between 0 and 10 to the 4th. R is greater than or equal to L, time complexity, linear, binary search tree, data structures, algorithms. Okay, I don't know. It seems to me like the only way to go wrong here, and I guess we could try like a little experiment with it, but you could traverse the tree, any way that you want to. In order, pre-order, post-order, and just check the nodes. Are they in the range? And add them. All right. Now, the only way I can see to go wrong here is, so this is a binary search tree. It's not just a binary tree, it's a binary search tree. And usually with an interview question, all the information is important. So if you're given some piece of information and you find that you're not using it, you should ask yourself, why am I not using this? Could I use this to improve my solution? So let's say you've got a binary search tree. I mean, we could use either one of these as an example, but like this one, the nodes have to be, the values need to be in a range of 10 to 22. So if we start here at the root and it's 22, everything to the right, everything in the right subtree is going to be greater than 22, and there's really no need to even look at it. Okay? Especially since we're talking about, we could have nodes, a number of nodes on the order of 10 to the 4th. So you don't want to, look at 10,000 nodes that you don't have to look at. Same thing is true down here, 8. 8 is not even in the range of 11 to 15. So anything in the left subtree of 8, no need to look at that. So I'm thinking, if you just do a traversal and look at everything, maybe it times out on, big trees. So I did add in here, we're doing an in-order traversal, by the way. So we have class variables, L, R, sum. We'll put L and R up here, sum initialized to 0, and then we'll call get sum, and then we'll return the sum. So here's get sum. This is a recursive. This is an in-order traversal. If the root's null, we'll just return. If the data is in the range between 0 and R, we'll add the data to sum, and then we'll do a recursive call to the left subtree and the right subtree. But we're only going to do a recursive call to the left subtree if the data is greater than L, meaning there might be something in the left subtree that we can use. Now, if the root data is less than or equal to L, there's no need to look at the need to look at the left subtree. That's the case that we have here, where the 8 node, it is less than L. So there's no need to look at the left subtree. Same thing here. If the root data is less than R, then we'll take a look at the right subtree. I want to run this and see what happens. And then I want to take the checks here off and see, could we just ignore the fact that it's a binary search tree, ignore the information that gives us, and still pass the challenge. All right, so submitting this. All right, all good. Now, if we took the checks off here and said, we're just going to look at every node, what would that do? Let's try it. I hope it fails, because there's no reason to make it a binary search tree and then have that information be irrelevant. Well, there you go. It works either way. So that's why the success rate is 93%. I have no idea why this is considered to be medium difficulty. So to recap, we've got a binary search tree. We have a range within which the nodes have to fall in order to be included in the sum. I would recommend, checking checking each node against the range, and potentially saving yourself quite a lot of work by not examining subtrees that couldn't possibly have data values within the range. But it does work even without that check. All right, so you can like the video. You can subscribe to the channel, and we will see you next time.